Physics Part 64. For example, a moving hammer hits a nail and as it stops does work to drive the nail into a piece of wood. Kinetic energy is energy due to motion. Consider an object of mass m moving with a constant acceleration a in a distance s. The object accelerates from velocity u to velocity v. Then by referring to the equation of motion, v square is equal to u square plus 2as. When the mass falls, it gains kinetic energy and drives the pile into the ground. By Newton's law, the force F giving rise to the acceleration a is given by F is equal to ma. Combining these two equations, v square is equal to u square plus 2f over m by s. Rearranging mv square is equal to mu square plus 2fs. 2fs is equal to mv square minus mu square and f is equal to half mv square minus half mu square. By definition of the term Fs, the work done by the force moving a distance x. Therefore, since Fs represents work done, then the other term is in the equation half mv square and half mu square must also have the units of the work done or energy. The magnitude of each of these terms depends on the velocity squared, and so half mv square and half mu square are terms representing the energy, which depends on the velocity or speed. The kinetic energy Ek of an object of mass moving with speed is given by Ek, which is equal to half mv square. For the kinetic energy to be in joules, mass must be in kilograms and the speed in meters per second. The full name for the term Ek is equal to half mv square, translated kinetic energy. Remember that rotating the objects also have kinetic energy, and this form of energy is known by rotational kinetic energy. Well, we talk about more about the kinetic energy and give you a few examples on it as well. I've got one first example. Calculate the kinetic energy of a car, mass 900 kilogram, moving at a speed of 20 meters per second. State the form of energy from which the kinetic energy is derived. Kinetic energy is half mv square is equal to half into 900 into 20 square, 1.8 into 10 power raised to 5 joule. The energy is derived from the chemical energy of the fuel. Now it's your turn. Calculate the kinetic energy of the car mass 800 kilogram moving at 100 kilometer per hour. A cycle and cyclist have a combined mass of 80 kilogram and are moving at 5.0 meter per second. Calculate A, the kinetic energy of the cycle and the cyclist. B, the increase in the kinetic energy for an increase in the speed of 5.0 meter per second. Energy conversion and conservation. Newspapers sometimes refer to a global energy crisis. In near future, there may well be a shortage of fossil fuels. Fossil fuels are a source of chemical energy. It would be more accurate to refer to a fossil fuel crisis. When chemical energy is used, the energy is transformed into other forms of energy, some of which are useful and some of which are not. eventually all the chemical energy is likely to end up as energy that is no longer useful to us.